Hi there, so today we're gonna learn how to make a dynamic weather system in Unreal Engine 5. Let's go. So we are in a standard UE5 project based on the third-person blueprint template, and I'm just going to show off the system that we are going to build. So there are several blocks on the scene over there. As we cross the blue ones, it starts to rain with a sound which is also playing at the same time. And as we cross the gray ones, it starts snowing. And if we cross the gray one again, the snow stops and the weather is clear again. So let's see how we are going to build that. So before starting, I'm going to use some assets in this tutorial. They are there. It's mainly particle systems and sounds. You can use whatever you want, but if you want to use those, I'm going to put them in the description below, so get them if you want. So first, let's create the main blueprint actor, which I call weather spawner, which will handle the spawning of the particle system as well as starting the sound, but you're going to see what it is used for. So we're going to call it BP weather spawner. So the first thing that we're going to do is to add the necessary components. First of all is the Niagara components to spawn the particles. Let's keep the default names. The second one is the audio component to play the sound of the rain or the snow or whatever you want. And the last component that we need is a box collision. So why do we need this box collision? Well, as you can see on the scene there is two overlap volume. And it was those ones that triggered the weather spawning when I showed it at the start of the video. And to detect that the player enter this box collision, I'm attaching this weather spawner directly to the player, and it is the overlapping between this box and those boxes over there that trigger the weather spawning. So that is why we need this box collision on this actor. And to make things clean, we can create a dedicated collision channel for those weather actors. It is there, I've called it weather. So you just need to click on this button, put the name, and you can choose the default response. For me, the weather I've put ignore because by default nobody cares about the weather collision. Now that we've got our collision channel and object type, we can go on the box collision parameters, and over there we can say custom collision, and we can say that this box collision is a weather object type, and we can say that it can ignore everything except the weather because because those box over there will have a weather object type as well, so it needs to be a weather and overlap with weather object types so that the overlap triggers. But we're going to see that a little bit better when we are going to create the overlap actors. So we've got our components. We can go on the event graph, and the first thing that we need to have is the actor to follow, because this weather spawner is placed, you can see it over there, it is placed wherever in the map, and at the start of the game it's going to look for the player character and attach to it. To do that, we just need to create, oops, I'm not in the right mode, an actor to follow variable, which will be an actor. And we just need to set this actor at the start of the game, so using the begin play node. And the actor that we're going to use is the player character that we can get using this node. And there we go. So now the actor to follow is set, but we need to well, follow it during the game. So to do that, we can use the tick node that is running at every frame. So we just need to branch to check that this actor is valid to avoid any errors. And if it is valid, we just have to set the location of this weather actor. Set actor location to the location of the actor to follow. Get actor location. So we could directly feed the location into the location for this actor, but it will looks a little bit glitchy. So to smooth that a little bit, we can use a v interrupt node using the delta second. Can we? Yeah, we can. Oh no. Well, let's take directly this one. So this one, the actor location will be the target, and the current rotation, well, will be the location of the weather actor. So don't forget that this one is the player character, and this one over there is the weather spawner. And for the interspeed, we can create a new variable, which will be the following speed, and it will be float, because we are going to decide of the following speed for each overlapping actor. You will see later how we can do that. But for now, let's say that this one is set by something before, and we're just going to feed the interrupt speed using this node, and we can feed that on the actor location. So for now, if we let's say that we are going to delete this one and place our weather spawner. So if we start the game right now and we exit, you can see that the weather spawner is attached to the player character, and if we move, it is still at the player location. So this part is working. Let's continue. So what we need right now is the logic that spawns the particles and the sound when it overlaps with an overlap actor. For that, we need a way to group all the parameters that a weather will have, which is in our case the sound, the particle system, as well as the following speed. In order to do that, we can create a blueprint structure. Let's call it fweather data, and we can start adding the parameters for weather. The first one will be a name, which will be the key. This key will be used to identify the current weather data that is playing. The second one is the particle system. It will be a Niagara system. Now the sound. This one will be a sound cue. There we go. We also need a parameter which is called amount. So I'm using this amount variable to control the amount of snow or rain or whatever you want. But for that to work, we need to go, for example, in our particle system, the snow one. If we go on the properties, I've exposed a parameter, which is this one, the amount, and I'm using it there on the spawn rate. The spawn rate is controlled by this variable, so the higher it is, the more particle will spawn. You can also skip this variable and just have a particle system that has a fixed spawn rate and that you find is working fine. And in this case, you will not need this variable. And the final parameter is the following speed, which will set these parameters that we have previously defined. And we are done for this structure. Now we need to define two functions. So the first function will be the setWeatherData, and it will be called when we are adding a new weather data. And the second one will be the clearWeatherData when we are ending the overlap, so to stop the current playing weather. But first, this setWeatherData. It will take as a parameter a weather data that we, oops, I forgot the data. The weather data that we have just defined. And so that it is easier, we can split the structure. So we are first going to branch and check if, oh yeah, another thing, we need to define a new global variable which will be the current key, and it is the key of the current weather that is playing, and we are going to use that to check if the current weather playing is the same as the one we want to add. And if it is the same, well, there is no need to do anything, so we just return and exit the function. If it is not currently playing, we can set the current key so that it takes this value. And then we can use a sequence node because we are going to do several unrelated things. And I find that the sequence node is pretty handy to do such things. So the first thing that we are going to handle is the particle system. We are just going to take the weather data, which is our parameter over there. We're going to split it. And we are going to check that the particle system is valid, because if it is not set, there is no need to do anything. And the next thing is to check if the component is currently active. if it is not, then we will activate it. Yeah, this one. But if it is, there is nothing to do. We can just let's take another one. Set the Niagara system. There we go. And it will come there. And the asset that we are going to use is the one contained in the data, this one. And we can also set the Niagara variable, which is the float, which will control the amount. And the parameter there, the name depends on the name that you have chosen in your particle system. I've named it amount, so that's why I've used the same name over there. So that's pretty much it for the particle. Let's put a comment over there so that it is a little bit cleaner. I mean, it's not really clean, but at least a little bit. And the second thing that we are going to handle is the audio, the sound. So same thing as the particle system, we are just going to check that the sound effect is valid. If it is, we just need to take our audio component and set the sound that we take from the data, and we can fade in so that the sound can be heard. And let's say 1 second, it's fine usually. And that's it for the sound. And the last thing that we need to set is to set the following speed. So yeah, let's take a new one. And we are done for our set weather data. So this function will be called when we want to spawn a weather. And now we are going to create a new function, which will be the clear weather data. And this one will be called when we want to remove a weather. So this one will just take a key. There the key parameter is useful because there can be a situation where we want to stop a specific weather. For example, if we cross this line over there, we would like to stop the rain, but if it's snowing, we want the snow to continue. So we will use an overlap like this, and we will provide the key of rain and say to on begin overlap to stop the weather data, so that only the rain stop there, and if it's snowing, it will be still snowing after we crossed the line. We need to do is check that the provided key is equal to the current key, and if it is, we can remove it. So to remove it, we are just I had it over there, clear the current key. we are going to deactivate the particles. We are going to reset the following speed to the default value of 1. And finally, we are fading out the weather sound. Let's say 1 second again. So that's it for this clear weather data. And we are done for our weather spanner. Now the next step is to create the blueprint for those overlap actors. It will expose a data parameter such as this, and it has 2 more parameters, which are those one over there, and it decides what we should do either on the begin overlapping and at the end of the overlapping. For example, I've decided that when we overlap it starts and at the end it stops, but we could do something where we want an overlap actor just to start the weather, and we just create another overlap actor to stop the weather. It makes the system a little bit more flexible. Let's create this actor based on the actor class still. There we go. So the first thing that we need to do is add a box collision. And this box, same as the collision box for the weather spanner, we need to tweak the collision so that it ignores everything except the weather, and it also needs to be a weather object type. So now this box and this box over there will trigger each other when overlapping. Let's go into the event graph, and we are going to implement the 2 functions over there. And as you've seen here, there is on begin overlap and on an overlap. So those ones are enum that we need to create. Let's say overlap type, and it will be either start, and let's start with the none. So if we, for example, if we say at the end of overlap none, well, it will do nothing. Start and stop. So now we can create our 2 variables which will take on newly created type. Let's create the other one. Let's compile, and let's say that by default we want to start, and at the end of overlap we want to stop. Now that's done, we can create a new function which will handle the overlap. It will take as a parameter the overlap type, as well as the actor that has overlap. Alright, so what we are going to do in this one is just depending on this parameter, we are going to call either the set weather data or the clear weather data. So the actor overlapping there, well, let's use it. It's going to be used like this. So on begin, we're going to use this one, and other actor will be the overlapping actor there, and it will be the same for the end overlap. We're just going to use, oh, I made a typo there. There we go. And we are going to provide the actor. So that's how we are going to use this function. And inside the function, we just need to cast to weather spawner. So that we can call, depending on the overlap type, and we can call, where is it? There we go. Let's switch on that. If it is none, we have nothing to do. If it starts, we are going to call set weather data, and we will give, oh yeah, I've just forgotten to create the weather data that is exposed, to choose the data we want either to add or remove for this for the overlap. So it is a weather data, and we're going to provide this parameter. Let's at least just put something there to be a little bit more clean. And if it stops, we just need to clear the weather data, and this time we can just provide the key. So that's it for our overlap actor. We just need to click on the eye over there so that those parameters are exposed, such as this, like that, and we can test if it works. Let's scale a little bit. So let's take those cubes. To put a visual indicator, and let's say, yeah, start and stop. Let's say that we want to start the weather at the start of the overlap and end it at the end of the overlap. We're going to call it snow. Oops. We're going to use the snow, the wind Q, and let's say it's going to snow a lot, and following speed 1. We could use 1 by default on the following speed there, so that we do not need to tweak it each time. And even the amount, we can put something like 500. Alright, we can test if it is working. And it seems to be working. Well, it's snowing with a bright blue sky, but that is another problem. And the snow have just stopped when the overlap has stopped, and it starts again when we overlap again. So that's it for this tutorial on dynamic weather system inside the UE5. If you enjoy the content, you can like the video or even subscribe and share the video if you really enjoyed it. You can comment as well. And that's it, yeah. So see you another time. Bye.